Hi, this is Raj Singh at the Spanovation Bridge and Seismic School. We provide career coaching for great bridge engineers like yourself. Today I'd like to present 4 simple practices to boost your engineering skills. Me and my partner Saqib Khan have articulated these practices from 40 years of combined experience in bridge and seismic engineering. We're confident that consciously incorporating these 4 simple practices early in your career will greatly accelerate your professional growth.
Let's start with the first practice. Sketch it. Some of the most skilled bridge engineers I've worked with rely on hand sketches to convey ideas as they take shape in their mind. This is because sketches are a quick and easy way for creative expression, brainstorming, communicating, and refining ideas into concepts. I find that these days, the value of sketching is not emphasized enough at universities and engineering offices. You tend to quickly jump on a computer even before concepts are clearly formed in your head. You need to change that. So whatever analysis or design task you're on, I'm sure you seek guidance from supervisors and peers as you work through the problem. Next time, attempt to convey your ideas through sketches, such as member outlines and sections for foundations, columns, caps, beams and girders, diaphragms and cross frames, deck, and so on. Make illustrations to support your calculations, such as loading scenarios, free body diagrams, demand envelopes, deflected shapes, stress and strain, struts and ties, and so on. Even though most of these can be printed from your computer program, making a few by hand will develop the skill. As you continue with this practice, you'll be surprised by the clarity this adds to your thinking, reduce errors, and the amount of time it takes to communicate and agree on solutions with your supervisor, especially for details such as reinforcing, post-tensioning connections, welding, bolting, etc. Your sketches do not need to be of exceptional quality. Let's leave that for architects. With basic attention to relative proportions, you'll be able to draw effectively. It will advance your skill set to conceptualize more complex components, span arrangements, and even developing entire bridge solutions. Second practice, visualize it. Training yourself to visualize in your mind's eye is a very important skill for a bridge engineer to gain a superior grasp of the problem, which is half the battle in coming up with innovative solutions. Here is a drill to build this ability. You would need a general arrangement drawing of a bridge or even a roadway drawing of an interchange. You would then review the drawing closely to memorize it and then try to recreate the geometry in 3 dimensions in your mind. You may even sketch the situation first to support your imagination. With daily 5-minute practice, you will soon be able to draw quick mental images of complex structural configurations. In addition to physical geometry, you need an aptitude to envision the flow of forces through a structure. This will help you gain a deeper understanding of structural systems and their fundamental behavior. For example, the suspension roof of the BC Place Stadium relies on a tension and compression ring to counterbalance the roof loads. Here is another fun drill to strengthen your ability to visualize the flow of forces. Always be on the lookout for interesting structures around you, from luminaire poles to cranes to bigger ones like bridges, buildings, stadiums, and airports. Try to piece together the structural system, cantilever, frame, arch, cable stay, etc., and make a simple sketch entailing a free body diagram. Next, attempt to figure out the load path for some simple vertical and lateral loads. Don't lose heart if you struggle. Take your sketches for discussion and insights from your peers or supervisor. Soon with this drill, you'll strengthen your gut feel for the behavior of various structural systems. Now you'll be able to better anticipate the results of computer analysis and will find it easier to troubleshoot majority of the problems yourself. Third practice, think big picture. It's easy for us to get lost in the weeds early in our careers, as there is so much to learn technically about various bridge types and all of their associated parts and pieces. Nonetheless, I would encourage you to develop the practice of stepping back and visualize ascending to a bird's eye view to understand the big picture of how your bridge fits into the larger scheme of things on the overall project and how other disciplines interface with yours. Your scope may not involve developing the configuration of the bridge, but ask your supervisor on how the general arrangement came about. Learn about the influence of highway geometrics on the bridge layout and vice versa. Are there other roadway alignment options, and why were they not the best suited? Ponder specific site challenges such as the need to maintain traffic flow along the highway corridor or continuity of critical utilities to the residential neighborhood. Would your bridge need to be built in stages to allow traffic flow during construction, or can you use the old bridge as a detour? Many other site-specific issues such as environmental sensitivities, hydraulic or geometric clearances, private property and right-of-way, proximity of railway lines, etc. impact the permanent configuration and construction phasing of your bridge. Make it your business to understand how those challenges were addressed, even though your task on the bridge may be limited to just the bearings only. If I had to pick one discipline that is most important for a bridge engineer, it would have to be geotechnical engineering. A lot of cost can get buried in the ground. Therefore, it's important early in your career to start developing a feel for the various foundation types, taking every opportunity possible to interact with geotechnical experts. Again, don't be shy to pick your supervisor's brain on the rationale behind foundation selection and all of the other multidisciplinary issues discussed earlier. Fourth practice, think construction. Early in my career, from working on cable-stayed bridges, I realized that the erection sequence has a major influence on the final stresses and geometry of the bridge. On crane-erected girder bridges, this is generally not the case, because of which most EITs don't need to give much thought to how bridges get put together on site. Without a basic grasp on constructability, it would be difficult for you to engineer practical and economical solutions. Therefore, it's important you open up your mind to the world of bridge construction through this exercise. On the project that you're working on, think of the various ways your superstructure can be erected: conventional crane stick build, cantilevering, incremental launching, etc. With the help of your supervisor, select the best suited methodology. Next, check for any locked-in dead load stresses unique to the erection sequence. For example, a girder bridge erected in progressive cantilevering has about 50% higher dead load moment above piers compared to conventional erection. This would need to be accurately accounted for in your design. For unconventional erection schemes such as incremental launching, you should verify that your superstructure has adequate strength and stability during all stages of erection. Think about how the girders will be transported and staged for assembly at site. Pick your supervisor's brain on logistics for transport, access for construction of substructures, right-of-way and site obstructions, and rough sizes and positioning of cranes. Working on paper all day, we don't really appreciate the scale of heavy civil operations and the challenges that construction crews must deal with to get your plans built. Therefore, take every opportunity to visit construction sites. Site experience will help you engineer better constructible solutions that reduce errors, cost overruns, and delays.